Hello everyone, let's find out the electric potential at a general point on the dipole. To understand this, let's consider a dipole and the distance between them is taken to be small. So, we'll take a condition where we have charge minus q and plus q. Let the center of this be some point C. Let this point be point A, this point B. In this case, let's find out the potential at some random point here. Let's call this point P, and the angle which it makes here is some theta. Let the distance from this charge be some R2 and this be some R1. So from here it will be R1. So this distance is called as R1. This is R2. This is the point C. The distance between C to B would be A, and from A to C would be again A only. So here also the potential would be the potential because of the plus charge and the potential because of the minus charge. Don't get confused that this is a single term and this is one more term. So don't think something else here. Let's find out what is V plus plus. So V plus is equal to, it will be K2 by BP, and then V minus would be K or minus here by AP. But in this case, the distance BP and AP are not same, because this R2 is less than R1. They are different distances. Basically here, if you want to put it in terms of R1, R2, this becomes by R2, this is by R1. They are different distances. Now let's find out what is R1, R2 first. Now here, from this point B, if we draw perpendicular onto this one, somewhere like this, perpendicular here, and call this point as some point M. If the angle is small here, example, call some angle here, this is small, in that case then R2 would be same as MP. So here R2, because you're dropping perpendicular from here, so R2 is same as MP. But the distance from C to P, this whole distance is R. This whole distance is R. So you can say MP is equal to, it will be R minus CM. That is what is MP, because MP is this distance. Let's find what is CM from this triangle. It's like this. This is point C, this is point M, this is point B, and here is the right angle. This is theta here, the right angle, okay? From here, this is a right angle which is 90 degrees, this is theta. So from this triangle, cos theta is equal to adjacent, which is CM, and then hypotenuse would be CB, but CB is same as A only, so CM by A. Therefore from here, what we get is, we get CM is equal to A into cos theta. Therefore this MP, which is R2, so R2 is equal to R minus CM becomes A into cos theta. This is what is R2. Similarly, what is seen is, this R1 is more than R. So just extends backward like this, draw it backwards, and then a normal drawn from here to here. So this becomes the perpendicular such that this angle and this angle is same as theta only. We'll call this as point N. So in this case, R1, that is this distance R1, would be same as this NP. Now observe carefully that we extend it properly here to the normal made. So this and this would be same. So R1 is equal to Pn, but Pn itself is equal to Pc plus Cn. Let's find what is Cn from this triangle. Again from here, this is the right angle. So from this triangle, if you look at cos theta, it will be adjacent side which is Cn by the hypotenuse which is say CAC, that is Cn by AC is A. Therefore, Cn is equal to A into cos theta. That gives us R1 is equal to PC, which is nothing but R, plus Cn is A into cos theta. So we found out what is R1 and what is R2. Let's put them back in the expression and see what we get from here. So V is equal to, it is KQ by R2 minus KQ by R1. From here KQ is common. It's 1 by R2 minus 1 by R1. That is KQ. 1 by R2 is R minus A cos theta minus 1 by R plus A into cos theta, that is equal to KQ. From here we'll take the LCM and cross multiply. So R plus A into cos theta minus of R minus A into cos theta is equal to, it will be R minus A cos theta into R plus A into cos theta. Do remember that there's a whole bracket here. Okay, this term here is equal to R minus A cos theta. There's a whole bracket here. Expand this. That will be KQ. It will be R plus A cos theta minus, open the bracket, minus R, and this term becomes plus A into cos theta, and this is of the form A minus B into A plus B, that is equal to R square minus this term square, that will be A square cos square theta, that's a single term. From here R gets cancelled and what remains is equal to, it will be KQ. This becomes 2 into A into cos theta by R square minus A square cos square theta. But Q into A is called as small p. Therefore, we get it as A P cos theta into R square minus A square into cos square theta. A short dipole. Short dipole means something of this kind. A short dipole here. This is the point like this. So look at, these are the two charges. This is minus Q plus Q. This is theta. Then in this case A is very much less than R. Also remember that, recall that cos theta maximum value is equal to plus 1. So if you square it also, if you put the maximum value of theta, it becomes just plus 1. So this is a very, very small number. So then what we get would be R minus A, R square minus A square. Again, since A is very, very small, this R square minus A square into cos square theta is almost same as R square only. That is equal to A P cos theta by R square. So this is the required form for the electric potential. We can write this in vector form also, because recall that A dot B is A into B into cos theta. We can write this as V as K P dot, we put R cap here, by R square, because the value of R cap is 1 unit in terms of magnitude, it's 1. So that P dot R cap is equal to, it is P into R cap value is 1 into cos theta. Also recall that vector P is from -2 plus Q. So the angle theta is between P to R cap, and R cap is pointing like this. This is what is R cap. It's pointing like this, and P is pointing like this. So the angle between them is theta. That's obvious. This is what is a net field. So in vector form, V is equal to K P dot R cap by R square. Now suppose if you put theta is equal to 0 degrees. If theta is 0 means then cos 0 is equal to 1. Then what we get is, we get V that becomes theta 0 means it's actual line only. That is, if you have minus Q plus Q, theta 0 means the point somewhere here, it's actual line, it's actual point in actual line. That is equal to V axial line. It becomes just Kp by R square. This is what we got in case of a potential due to a dipole on the axial line. Similarly, we take a case 2. Case 2, if theta is equal to 90 degrees, then cos 90 would be 0. So 90 degrees would mean that it's some point like this. This is the point somewhere here. It means it's on the equatorial line, 90 degrees. So V on the equatorial line is equal to 0. We have proved this separately by using normal formula for electric potential, but by knowing single formula we can get these two. So remember this formula, because sometimes in some exams they'll ask you for a different angle. It may not be exactly on the equatorial line or axial line, could be some angle also. This is what is the field. Observe that the field, this is the potential. Observe that the potential goes as 1 by R square. So this is the required expression.